What's up, Algebra 1? Tokar back at you with another day of finals review. We are looking at relations and functions. So at the top of your paper, your topic is relations and functions. Remember, this first slide we're going to go over, I'm going to just give you a quick mini lesson to talk about some important vocab, kind of a brief covering of what we are going to do that you can always come back and revisit. When we start filling out our notes, you will know my screen will look just like your note sheet, and that is when you're going to need to write, but feel free to take note on a scratch piece of paper. Today, all about relations and functions. Let's talk about what those are. A relation is a set of ordered pairs, an x and y. It's a point. It's a bunch of points, where x represents our input, what we're putting into the relation, and y is what we get out. We put a number in, stuff happens to it, and it spits out a y value, an output. Now, a function is a special relation. A function is a relation where every input, every x value has only one output. A good way to remember this is it is going to be a function as long as you don't have any x values that are exactly the same. All of your x values have to be different. You cannot have repeating x values. Y values, you could have as many repeaters as you want, but x values, only one of a kind. So let's kind of look at the three different little formats. We have mappings, we have tables, and we have graphs. We need to be able to tell if mappings are functions, if a table is a function, and if a graph is a function. So let's do a brief overview. Our mappings have input side and output side. We have our x on the left, and we've got our y on the right. Input, output. What we are looking for is, do each of our inputs only have one output? So if I look at each of my numbers one at a time, 0 only has one output. That's good. 2 only has one output. Very good. 4 only has one output. 3. And 6 only has one output, one arrow. So this first one is a function. Now, if we take a look at the second one, -3 has one output, 8. -2 has one output, 2. However, 1 has two outputs. It has -1 and it has 8. Because this mapping shows an input, 1, having two different outputs, not 8, 5. Since 1 has two outputs, a -1 and a 5, this fails. So this is not a function. Now we can do the same thing with a table. When you are determining if it's a function, you only care about the x. You only care about the inputs. Now, if we're looking at only our inputs, we can see that I have a -2, I have a -1, I have a 0, and I have a 1. I do not have any repeats. If any of these repeat, then it fails. Since all of these numbers, -2, -1, 0, 1, those are all different numbers, so this is a function. If we take a look at our second table, here are my x values across the top. I have 0, 2, 0, and 2. You can see this is a big no-no. I have a 0 that repeats. I have a 2 that repeats. This is a double fail. If I have an x value that shows up more than once, it is not a function. Last but not least, a graph. If you are given a graph or asked to graph an equation, how do we determine if it's a function? We use what is called the vertical line test. You will take a pencil, you will hold it vertical, straight up and down, and you will slide it across your graph. If your pencil or your finger ever hits the graph more than one time, it fails and is not a function. So if I slowly slide this past, my pencil only hits my graph one time. No matter where I put my pencil, it is never hitting the graph at more than 1 point. So this first one is a function. Lastly, one more graph. If I take my pencil and I put this and slide it across my graph, I can see that my pencil is hitting my graph not once, but twice. And it does it in a lot of different places. If your pencil hits more than one time, like this circle, then it is not a function, and it fails the vertical line test. If you are asked to explain your reasoning, you can use this as a reason. Number one, this graph is a function because it passes the vertical line test. The circle is not a function because it fails the vertical line test. That is your reasoning. This is everything you need to know for relations and functions. Let's get into our problems. Number one, remember, we are doing our 3-step good habits for test taking, question answering. You always want to do these 3 things, but we are going to begin to write down on our notes. Number one, we're going to read the problem twice. Number two, we're going to write down what the question is asking us to do, and then we are going to state our givens. Before we do that, pause the video and you copy down number one into your box like I have done. Take your time, write neat. All right, you've written down your problem. Number one, let's read the problem. Not once, but twice. Number one, determine if the relation is a function. Why or why not? One more time. Determine if the relation is a function. Why or why not? We have read the problem twice. What is the question asking? The question is asking us, is it a function? 2-step parts. Is it a function? And then it asks us why. So we have 2 things we need to do in order to get this question. We need to determine if it's a function, and then we need to write down why or why not. Is it a function, and why? Check it off. Lastly, what are we given? We are given a table. We are given this table. This table is everything we need in order to determine if this is a function and answer the question why or why not. When we're determining a function, we only care about the inputs. We only care about the x values. We do not care about anything else. So our focus is right here. We are trying to figure out, do all of our inputs have one output? Let's see. I have a -2, a 0, a 4, a 2, and a -1. None of my x values repeat. So this is a function. So let's answer our first part. Part 1. Is it a function? Yes. The table represents a function. And now we need to answer the question, why or why not? This is a function because, or if it wasn't a function, this is not a function because Well, every input, which is x value, has exactly one output. That is our reason why. And we're done with number 1. Forgot to check off our given, but we did do that. Number 1, all good and done. Okay, get that down. Next problem. Number 2. 3 steps. After we copy it down, so pause the video and copy it down in your box, write down number 2, write nice and neat, draw your table so you can look back at this for help. All right, you've written it down. 3 steps. Step 1, read the problem twice. I want you to pause the video and read this problem twice. You've read the problem twice. Complete the table so that it does not represent a function. We've read it twice. What is it asking, and write it out? This problem is asking us to first complete the table. And it specifically wants us to do it in a way so that it does not represent a function. So first, complete the table. Complete the table. Write it down. And we need to make sure that we do it so it's not a function. Complete the table so it's not a function. So remember, when we are completing a table, when we are looking at a table, we only look at the x values. Only at the x values. We do not care about anything else. And our rule is that it is a function if none of our x values repeat. But we want to make it not be a function. So I need to make sure that whatever numbers I put in the top row, I have at least one x value that repeats. So take a second and try filling out your table. Okay, so maybe you had -2 show up twice. If you have -2 show up twice, it's already not a function. Maybe you had 5 show up twice. If 5 shows up twice, not a function. Maybe you were super creative and put in your own numbers, like 1 and 1. If you have 2 numbers that repeat, it's not a function. Okay? Maybe in my example, I'm going to have a 3, a 4, and another 5. This is not a function because I have 2 5s. Now remember, our y values do not matter at all. You can put any numbers you want in your y because they do not determine if it's a function or not. So let's just put in some numbers. 3, -1, 6. Those could have been any number. Y value does not matter. All that matters is that you have an x value that repeats. So, complete the table so that it does not represent a function. We have done that. We have answered what it is asking of us. So we are done. Number 2, done. Okay, number 3. This is a long question, and I know you may not want to write it all down, but you need to write it all down in the box. Number 3, write it all down. Pause the video, take your time, make sure you can read your writing. Already go. All right, you have copied down your problem. So it is now time to read the problem, not once, but twice. So go ahead and read your problem twice. Okay, so you've read your problem twice. Select all of the sets that are functions. What is it asking us? It's asking us to select all. So we know we might have more than one answer. And we want to select the ones that are functions. So we are going to select all, which means there could be more than one. Could be more than one answer. And we want to make sure that they are functions. Okay, select all, and we're going to make sure that they're functions. So what did the problem give us? It gave us all 4 of these sets of points. So that is everything we need in order to determine which ones are functions. So let's look at each point. Now, these are just another way of writing a table. Each one of these points has an x and a y value. So if we look, we have an x and a y for every single point. Now, we're only focused on the x values. So I'm going to highlight my x values. X value, X value, X value, X value, X value. And remember, I'm trying to determine, do any of my X values repeat? I have a 1, a 2, a 3, a 5, and a 6. No repeats, so this is a function. And remember, I'm trying to figure out, select if it's a function. So this is a function. This is a function. Same thing, I'm looking at all of my x values. And I'm trying to see if any of my x values repeat. When I'm looking through this, I see a -1 here and a -1 here, which means this is not a function, so it does not get selected. We only select the function. So the second one, not a function. Do not select it. Third one, 0, -1, 4, 0, 0. This is definitely not a function. Why? You guessed it, a 0, a 0, a 0. 0 shows up 3 times, so this is definitely not a function, which means we do not select it. We are only selecting our functions. Last one we're checking. I have a 1, a 2, a 4, a 5, and a -5. Now, I don't see any x values that repeat, so this is a function, so we select it. So we have selected all of our functions, and we have not selected our non-functions. So our answer, the first one and the last one, and we're done. Last problem. Number 4. Take a second, write down number 4. Make sure you write nice and neatly. And make sure you get Desmos open. Alright, so you've written your problem down and you have Desmos open and ready to go. So let's start by reading the problem twice. Read that problem twice and resume the video when you're done. Okay, graph each function in Desmos and determine if the relations are functions or not. So we are done. What is it asking? It is asking us to graph the function in Desmos and then to determine if the relations are a function or not. So we need to first graph in Desmos, and then we need to determine if it's a function. What is it given? It has given us equations. It has given us equations. Okay, so let's start to determine if these are or are not functions. So our first one is, I'm going to go on to this side. Our first one is y equals negative 2x plus 3. So here is my graph. Now, take your pencil and let's perform the vertical line test. I have a little line here you don't have to worry about. As we move our line across, does our line or your pencil ever hit more than once? No, we never hit more than once. So this is a function. Check. Number 2. Clear out your last function. Y equals 1/2. Make sure you push the over arrow. X. And we want to do to the power of, so I put a to the b, 3. Take your pencil. In my case, I am pulling up my little line, and I'm sliding it across. Does my line ever hit more than once? No, it only ever hits one time. So this is a function. 2 more. Okay, clear out my old graph. Y equals, y to the second power equals x plus 4. Here's what my graph looks like. And if I slide my point across, I can see that my line hits more than one time. So this is not a function. So we do not select it. One more. X squared plus y squared equals 16. X squared plus y squared equals 16. If I take my vertical line or your pencil and slide it across, I can see that my vertical line is hitting my graph more than once. More than once. So this is not a function. And that is the end of our review. What you're going to do is go ahead and go to the next slide, and you are going to do these 4 problems on the back side. Please make sure that you copy the problem down, read it twice, write down what it is asking you to do, and writing down your givens. Good luck.